Circle Optics, our mission is to deliver situational intelligence for a safer, smarter, more immersive world. And through our patent stitch-free Parallax panoramic imaging systems, we help defense, aerospace, and robotics professionals improve how they perceive and respond to their environment. At this time, Circle Optics has 18 employees, some interns, and a couple of consultants. We have 23 patents and pending, and are very excited that we're actually beginning to do work outside and beginning our commercialization process. And because of that, it was really exciting for us to begin to think about how do we tell our story, not just with Zach and Ian, our founders and COO, but also the people behind the scenes that are actually putting the optics, mechanics, and software together. And so this is the second of the Stitchless episodes. Before we had Zach and Ian talk a little bit about their vision for the technology and a little bit about the systems. This particular series is going to be with our mechanical team. And I'm so grateful. As many of you may know, people in mechanical like to solve problems that haven't been solved before, and often like working with technology more than people. So asking people to come in and really share their voice is quite a flex for the team. And I'm so grateful that they came in to do that. I'm actually going to have each of them introduce themselves, share how long they've been with Circle Optics, and really talk about how did you get into mechanical engineering. And I've been working with Carlos the longest, who has been at Circle Optics the longest. So Carlos, let's start with you. Please introduce yourself and share a little bit about your background and what really made you choose this field.
Yeah, my name is Carlos Terrero, and I have been in Circle for 3 years. And what attracted me to mechanical engineering, I actually arrived to it indirectly. I didn't know what engineers were or did when I was growing up. I didn't have that type of role model in my community. But thanks to my teachers, I was able to find something that I would be curious in. And essentially, especially my math and science teachers, I really liked physics, high school physics. And my teacher was very unconventional. I don't remember him doing lectures. He would just have us go outside and do experiments or bring things from the real world as examples. I remember him bringing in a microwave, and I remember him opening it up and us dissecting how it worked, and surprised on how simple of a machine it was. And those type of things kind of sparked my curiosity into technology. And that's how I got into mechanical engineering, which is the practical application of physics. So that's how I found it, and I'm glad I did.
And I have to actually make a correction already so early in the program. Bob actually has been at Circle Optics the most, and it just kind of tells you how much proximity matters so much. I work right next to Carlos. And so, Bob, please forgive me for not acknowledging your extra years at Circle Optics. And I'd love you to introduce yourself and where you came from.
Yep. So I have been at Circle Optics for 5 years, and it's been a really good ride so far. And all the people that I've worked with are great. My urge to get into engineering really began when I was a kid. I really liked drawing. I thought all I wanted to do was make cool drawings, and I first started out with things that were more like scenic landscapes and things like that. But then I started to realize that I could put my thoughts down on paper in my thoughts of how to solve problems. And I started out, building forts when I was a kid, and I would draw them out before I would build them. I would hold up the rest of my friends because I had to draw it out on paper. But it was that kind of really got me started, and I really love conceptualizing and putting something down on paper that no one's ever seen before. That's really what excites me.
And you came from Carestream before?
I came from Carestream, and prior to that, Kodak.
Okay, so you've had a lot of different applications with your drawing and that sort of thing. It's great. Sure. The newest member to the team, actually, the newest hire that we've had is now Matt, and it's different roles. You want to introduce you and your role, and then a little bit about your background?
Sure. My name is Matt Brophy. I've been with Circle Optics now for 4 months. My title is optomechanical technician. I originally basically started off going to school for imaging science, so I wasn't really going into the mechanical direction, but I do have quite an interest in mechanical types of applications. Growing up as a kid, my father used to build go-karts with me, and I became really interested in figuring out how to put it together, and then how to improve the go-kart, how to basically create modifications for it. And then over time, I eventually got dirt bikes and four-wheelers, and I basically did a lot of modifications on my own on those, and just kind of built upon the foundation that my dad kind of like set up for me as a kid. So I had basically worked in optics for a number of years. I worked at IDEX for 8 years as a engineering technician, and then saw the opportunity over at Circle for the optomechanical technician role, and took the role. And I felt it was a very good fit for me because I have a lot of experience in optics, and I have a fairly good mechanical aptitude, and just have a lot of experience basically setting up test setups. So I felt it was a very good fit for me. I'm very excited to join the team.
It's very great. I'm interested in each of you, and I'm going to start with you, Bob, this time around. How do you define craftsmanship in a high-tech environment, and why is it that the integrity matters so much more in optical systems, or is that a false premise?
Yeah, I'm not too sure that it's a false premise. I think, mechanics in optics are, they kind of, yeah. Sorry. Could you repeat that?
Oh, yeah. Yeah, I was trying to kind of combine. One of the questions was about why is integrity matter so much more in then optics. But then I was thinking, like, is that true that it matters more? Because I think it matters more, but I don't know that that's true just because you've worked in other domains.
Right. So I think in optics, it comes down to tolerances matter so much in optics, probably compared to a lot of other things. So what we do in the mechanical side of it is we need to make sure that we're doing everything that we can to get those optics, if you will, setting in space where they need to be relative to each other, so that they're pointing and so that they're performing the way the optical engineer has designed them to work.
And is there a certain craftsmanship? I always think of I admire mechanical engineers so much because there's such an art and science to it. Is there a certain mantra that you have, or a certain way of preparing your space that that might be different than Carlos's or Matt's, or is it just something, craftsmanship? What does it mean to you?
Craftsmanship to me means being about as exact as you can on how you're doing something, whether it's laying out the whole system or just a single part. They all fall together and make that full system exact. And that's where I talk about tolerances, and there's tolerances on everything, and you need to be aware of the tolerances on your part, on the neighboring parts, on the optics, on the electronics. So you're really pulling things together so that they fit together and perform the way they're supposed to.
Great. Thank you. Carlos, how about you? What is your approach to craftsmanship and the reason that the integrity has to be so accurate for us?
Yeah. Regarding the integrity, essentially our systems, the novelty is in the optics, and we have to play a part in it as mechanical engineers in order to fulfill the potential of the optics. So we have to, like Bob was mentioning, have to locate these channels, these camera channels, very precisely, one relative to each other, and that's where the integrity comes into play. Like I mentioned, just to get the potential of the optics fulfilled.
Cool. Matt, same question.
I'm sorry, could you repeat the question?
Yeah, just asking a little bit about your approach to craftsmanship and why integrity matters so much, in particular to optical systems.
Integrity matters because if you don't have it, it's just not going to work in general. Basically, there's a lot of details. You really have to pay close attention to detail. And if there's something that's missed, basically something really, really small is going to cause a problem where the system is just not going to work or the test isn't going to work. So it's really just basically really key is attention to detail, understanding how things work and understanding like, okay, if there's something that's not working as well as you expected to, why is it? And what do you need to do to improve that? It's really, for me, it's just kind of come over time, but also I think it's a little bit natural maybe too for myself. But also it's, sometimes I need to get like a second opinion on things. I might think that, okay, this might be the issue. And I'll ask the engineers, okay, what do you think about this? Do you think that maybe I'm on the right track or do you think it could be something else? And, yeah, it's good to have a second opinion sometimes just to kind of get confirmation that, okay, this is really what's going on or it's not. So.
What is, I'm going to start with you this time, Carlos, is, what is your favorite part of the build? Seeing a concept go to reality? Is there a certain part of the phase that are, or maybe even talk about the different phases from a concept to actually seeing the technology? For our listeners, our very next episode is actually going to be specifically on our Pegasus system and our Hydra 3 system. So there'll be a little bit more nuts and bolts about what we're actually building. But on this one, I'd like to ask you, what's your favorite part of the build?
My favorite part is when it all comes together, especially when we're working on problems that have never been solved before or people have never thought of solving before. Our systems the novelty is in the optics, but mechanically that brings some challenges. For example, we have most of our lenses are truncated. So we have multiple faces that are truncated on the lens. So it's not a round lens like you typically see on a camera. And where that comes into play is that the image sensor is square or rectangular. And for a round lens, it doesn't matter the orientation of the lens relative to that square or rectangle. But for our system, it does. We have to align our truncated edges to the sensor. So we had to devise things in the design and also all the way through to manufacturing and testing to ensure that. And one of these things was a mechanical fixture for assembly where we aligned the sensor to the camera. And this has never been done before because it's a new problem that has arisen because of our technology. And we were successful in doing it. And, when it all came together, we're very pleased and happy.
That's exciting. How about for you?
The exciting part for me is when you start seeing your parts come in real life and working with the vendors to make sure that they're right. Sometimes they call up and say, hey, we blew it on this dimension. What about that? And they're all worried about it. And you look at it and you go, yeah, we're fine. We're good. We can use that part as is. Or you got some other changes to make on it. And you work with them to work that out the cheapest, fastest way possible. But then you get those parts in your hand and you check them out. You start fitting them together, and you start seeing how what you had on paper or now in the computer, how it really falls together and works, and then you start actually getting your hands on the parts and putting them together, and that's a lot of fun to do. Just like Matt was saying, just working on equipment is it's a lot of fun, and it really pulls the team together to get it done. And then the next exciting part is actually getting light through the lenses and seeing what it looks like on that sensor, and then working with your software people to make sure that we've delivered what they need for an image and that they can work with it. So that's really a part of the job that's really cool.
And you having been here for 5 years, a couple of weeks ago, we did some flight testing. For the first time, our Pegasus system is actually on a drone and flying and doing the situational intelligence. And I can't imagine what that's like for you, having, like when I came in working with hardware is a lot, it takes a lot of patience. And so I can't imagine coming in, and 5 years later, finally seeing it in flight. What is that like for you, this particular phase where we are?
It's almost like when you see a NASA team sitting in that room and everybody stands up and they're cheering because they finally saw what they worked toward, either being blasted off or being employed or deployed into space. And so the whole team's cheering, and it's just great to see it out there and working, and just excited for the next stage in that product.
That's great, Matt. And you're almost like, talk about perfect time to join our team, because we're at a tipping point. And so you're kind of right here at a time where things are really beginning to get some traction. From the process, what is your favorite part of, and again, I don't know that much about optical mechanical technology that you're doing. What is the process, and what's the most fulfilling part for you?
That's a good question, actually. For me, the most fulfilling part is once I have the optics in hand, we have the test set up, we have everything set up. I started using this device called the OptiQuiver, and it took a little bit of time to figure out how to integrate and use the software itself, and then basically figure out how to align to it, how to test with it. And there's a lot of challenges that came up which were kind of unexpected, and certain challenges and issues that I've never seen before. But basically over time, slowly but surely kind of worked through a lot of those issues. And once we started actually having some success and actually getting, some wavefronts off of these lenses, that, it was just little baby steps where I started feeling little small steps of success. And then kind of find out, we had, some issues that were related to the fixturing, and just the test results were just showing some inconsistencies. I know we've addressed that and worked through those and found basically alternative approaches to testing where we could properly characterize the lenses. And once we were able to kind of do that, at least establish a baseline, realized that we had a few issues with some of the lenses, and then it didn't take very long to figure out what those issues were, and then basically improve them, and basically at this point have most of them in a good working functional state, and that's very gratifying.
That's great. As the company is growing and getting prepared for commercialization and scale, it's really important that we have an understanding of who are the people and what is the DNA of the people on the team. And Bob was very involved in our initial process of really kind of identifying the identity of Circle Optics and what it means to be a Circle Optics employee. We came up together with the team 3 phrases, not really phrases, but words. Like, our brand is based on a DNA strand of innovation, know-how, and synergy. And the reason I want to bring that up is that, Bob, I remember you saying when we were talking about attention to detail, you said, Jennifer, we want to know the branches, we want to know the trees and the branches on the tree. Can you talk a little bit about that attention to detail? I just thought that phrase I'd never heard before. It's so beautiful, and I tell everybody about it.
Yeah, so, I'm not alone in the mechanical engineering group that we're just all about doing it like perfectly from the start, which is impossible, right? But the details for us, much like the branches or even the leaves, we're zeroed in on specifications, and those are the details for us. And as you start to work toward doing product design, where you're going to build more than one, you start to worry about the specifications. Was my specification right? And did my parts meet that spec, whether tolerances or whatever? But that's the kind of detail that I look at to pull the product together.
Yeah, I love that. The trees and the branches on the trees. Very, very amazing insight there. I have just 2 more questions for this phase of it. And one of them is, innovation is one of our core pillars. And, Zach founded it on the question of what if innovation. But with innovation, you're doing things that haven't been done before. And so failure and failing and iterating are part of that. How do you how do you handle failure? How do you get resilience? And I'll start Carlos. We'll go Carlos, Matt, and then Bob.
Yeah, it's about incorporating the lessons learned from previous iterations into a new design. For example, I know that the original Hydra was, very tight tolerances, over constrained. They were intending it to be, robust. But for example, I know I've heard the story of Ian going to New York City on a sunny day, and one of the lenses pops out, and it was believed that the thermal expansion due to the heat caused things to shift, caused stress in the system, and we were able to learn from that. When I came onto the team, luckily for me, it was very documented how this design worked, and this fader mode specifically, and how it came together, and we were able to take that information and, for example, the frame that holds all the lenses together, we reduced the number of parts, which made it simpler, easier to tolerance, and easier to put together and service, take apart. And so it was all about taking what we learned from the past and incorporating into the newer designs, which was very satisfying.
Very cool. Yeah.
Well, I'm sorry, can you repeat the question again?
Yeah. No, that's fine. I think I just want to get into iteration and failure. How do we strengthen our tolerance for failure, and how do you approach failure?
Approach failure. Well, it's something that I hate to say it, it's kind of come to be expected with basically prototypes. Like Bob mentioned before, it's not going to be perfect the first time. Ideally, it is. You attempt to have success. You're not trying to fail. But basically, you can't really let that break you necessarily, but you pretty much just learn from it. It can be a little bit frustrating, but at the same time, too, it's just part of the job. It's in a way, it's to be expected. Not that you want it to attempt to fail or trying to fail, but it becomes sort of part of the learning curve too, as far as just kind of, okay, well, this didn't work. So that, you actually learn from that, and you basically kind of make an adjustment and figure out, okay, why does it work? And we need to figure out what we need to do to get it to work, and we do.
Great. Persistence. Great.
Yeah, so one thing that I've always liked to do in design is to always have a way out in the back of my mind. When I'm designing something, whether it's I might need a little more space, or you have to use a different material or process, you try to not box yourself into a corner, because you know that it's not going to work the first time, and then that gives you a way to change something without starting from ground up again. And I'm just really glad that at Circle, the other engineers that I'm working with, they're all thinking like that. So when we do have something that goes wrong, we usually have a pretty quick out on fixing that. And that when you're only doing like one prototype for start, that's really important that you can react and change it up. It's not like software where you just get rid of a few lines of code, put a few more in, and you're on with life. You just run it. We have to. Our stuff takes a little longer, and certainly in the optical side of things, it's prototyping and optics has just not quite come around as far as some of the mechanical parts. It just takes time for them to make those parts for you, those optics, the lenses. So that's
that's it. From all of you, I hear clarity, persistence, and scenario planning are all really fundamental skills. This next question, I hope you find fun. And it is either the idea of, if you were mentoring someone, what's a lesson you would tell them or you would share that would be great? Or what would you tell your younger self, knowing what you know now in the career of mechanical engineering? And Bob, are you open to starting first on that?
Sure. I've been asked this question a few times when we've had some students in, we've talked to them. And my first answer is always ask a lot of questions, because you need to know exactly what somebody wants you to give them in the end. And so you're going to ask them questions as you go along. Just what does this thing have to do? What's the shape? What kind of materials do I need to use? What color does it need to be? All these things matter in the end design. And a lot of times they're not going to have the answer. So you keep prodding them and ask that customer, that lead engineer, what do you want from me? What do I need to design? And that usually gets you to deliver something that's typically beyond what they were expecting.
That's great advice.
I think documentation is very important. So my advice to me in the past, or to any young engineer, is to keep a journal or a design notebook that you're updating every time, everything you're working on, because you could always go back and reference that. And it's a very nice communication tool to have. And now you can do it electronically. You can, have a Word document or a PowerPoint that you keep for every project, documenting your progress. And if a question comes up in the future, it's easy to go back and reference that and not have to redo the work or rethink how you got there. So that would be my key point.
Excellent.
I would say I would kind of agree with Bob and Carlos as far as the combination of ask a lot of questions, lots of documentation. And if I was to give advice to myself or say someone I was mentoring, I would suggest basically learn as much software as you can. Try to, basically learn SolidWorks early on if you can. Learn as much programming as you possibly can when you're younger. It just gives you more tools to be able to work with when it comes to working in a mechanical type of environment. The more tools you have at your disposal, the more chances you have of being successful.
That's great. You've been listening to Stitchless Circle Optics in Focus, featuring our mechanical team. Thank you for joining us.